Hi class, welcome to the tutorial session that is on Finite Impulse Response FIR filter system. Today I am going to show you how to deal with the different kind of problems of FIR filter system, especially how to illustrate the block representation, determine the direct form realization, and of course how to sketch the direct form of a filter from a given transfer function. Okay, let's take a look what's in your tutorial 6, that's on systems for filtering. In question 1, you are asked to illustrate the block representation of the given system functions. So, before we proceed to solve the question, we must know how the basic components of a filter structure look like. Here, you can see the fundamental components of a filter structure that are adder, constant multiplier, signal multiplier, delay or unit delay or memory, and a bonus. The adder is responsible for adding signals. Let's say if you need to add two different signals x1 of n, x2 of n, and x3 of n to get the output y1 of n, then you can simply draw like this. The constant multiplier can be represented by a single arrow placing the constant value along with this. Signal multiplier multiplies two or more signals, and delay or memory unit stores the previous input. Okay, I'm not going too deep what's already covered in your class lectures. Let's solve the question. Look at the question 1a. Here you are given a difference equation. Just rearrange the equation. If you look at this equation, you can easily understand that this is representing a simple filter to add up t different input signals. Let's draw the block representation. Now move to question 1b. This is almost the same question that we solved just now, but here's a bit difference. In question 1b, there's two different input signals, 4x1 of n, 2x2 of n, and x3 of n are equated to form the output signal y2 of n. However, 4x1 of n and 2x2 of n are multiplied by each other and then added to xn of t. So we can represent this difference equation of filter like this. Let's see what's in question 2. In question 2, you are asked to determine the direct form realization for the following linear phase filters. This question is completely different from the previous one. Here you are given three different sets of impulse response h of n that represents three different linear phase filters. To deal with this question, we need to form equations that represent the input-output relation of these filters. I mean, if xk of n and yk of n are the input and output of these filters respectively, then we have to form functions relating xk of n and xk of n and yk of n. Okay, let's see how we can solve this. Here, h of n is representing the sequence of a linear phase filter's impulse in discrete time domain. First of all, we need to find the G transform of h of n, which is h of g. And that is nothing but the transfer function of the entire filter system. Here's the formula we need to follow to interpret h of n to h of g. Look at the formula. What is the capital N means? The capital N is the length of the sequence of the impulse response h of n. In this question, h of n In h of n, capital N is equal to 7. Here n denotes the order of the sequence, which is n equal to 0 to n equal to n minus 7, sorry, n minus 1, which is 6. Meaning in this sequence, if n equal to 0, then h of 0 equal to 1. When n equal to 1, then h of 1 equal to 2. When n equal to 2, h of 2 equal to t. When n equal to t, h of t equal to 4. When n equal to 4, h of 4 equal to t. When n equal to 5, h of 5 equal to 2. When h equal to 6, h of 6 equal to 1. G inverse n is nothing but the number of the delay unit. Okay, let's transfer h of n to h of g. Substitute the value of h of n here. So now we got the transfer function h of g, and we can find the function of x of z, x of g, and y of g as h of g. Here we can write the equation like this. Now we need to perform inverse G transform to get y of n following the inverse G transform formula. Here's the inverse G transform of y of g. Okay, now we are almost done with this question. Only need to draw the direct form for this. To draw the direct form, we need to insert the delay unit and error. According to the equation of this filter, we need to add 7 different signals. Now the fact is, how many delay units and errors are needed to insert in your sketch. To sketch the direct form, we need to insert n-1 delay units and errors. Let's see how to do it. As n equal to 7, insert n-1 equal to 6 delay and errors and connect them accordingly. And this is the answer of question 2a. Okay, now have a look to the question 2b and c. These are the same questions as 2a. So, if you understand the procedure to solve this kind of problems that I explained here, you can easily understand how to solve 2b and c. Here I am not going to show you the steps involved in solving the problems 2b and c in details. Just providing the solution of these problems. So go through the solutions. I believe you can understand how it's done. Thank you and best of luck.